Julia. Okay, so then what do we get for our x-intercepts? 0, 0. Okay, did I do anything wrong? I'm just saying.
That's what I got.
Okay, step in your calculator. Now you got to get out the calculator and be looking at this graph because we're basically just trying to graph this with calculator.
Yeah, because while you were drawing it was Caleb.
Yeah, it was insane. We had a whole page of limits to do, and you weren't here. And so there was nobody there to tell us whether our answer was right or not.
Oh, yeah.
Okay, determine any vertical asymptotes and horizontal asymptotes for the curve. How do you do that? Vertical what? The bottom equals 0, yeah, so since this is to the negative x squared, we need to rewrite it as x over e to the x squared, but when does that equal 0 on the bottom? Never. Never. Nunca.
Nunca.
Never.
Why did you put that on the bottom?
Spanish.
Oh, to make it positive.
Oh yeah, it is, huh?
Uh-huh.
What's German?
Never.
German for never?
Nevada.
No, that's like Italian or something. German would be
That's why I thought that was German.
Never.
Want me to find out? I have a translator app.
Okay, and then what are the horizontal asymptotes? How do you find those? Okay, so you figure out the limit of this as x approaches positive infinity.
We want German?
Uh-huh.
Never for never.
Legal.
What?
Oh, no, that's not what I want. I think they'll say it. Pasta is enough. Because there's a guy with a big restaurant around here or something.
Okay, so this is fun to find the horizontal asymptotes. You have to find the limit as x approaches infinity. So if you plug infinity in there, what do you get? What do you get?
What?
Infinity over infinity. And so how do we solve that problem? L'Hopital's rule, so we take the derivative of the top and the bottom. The derivative of the bottom is going to be e to the x squared times 2x, and so right, if you plug in infinity into that, now you're going to get a horizontal asymptote of 0. Can you confirm that? Okay. Same thing if you plug in negative infinity, it's just going to come out to be 0 on that also. Okay. So we have a horizontal asymptote of y equals 0 and a vertical asymptote of none. That's different. Okay, find all the critical numbers. How do we do the critical numbers?
And to take the derivative, we have to take the natural numbers, right?
Take the derivative and set it equal to 0. Nope.
No?
Because this is not a variable in the base.
Right.
I know, I figured that out. Yeah, it's got to be a variable as the base and a variable as the...
We don't have to take the second derivative, do we?
Not for critical numbers, but I'm guessing we're going to have to for stuff.
Enter.
Tara.
Stay out,
Hi,
skipper.
Tara.
Come in.
Skip my class.
We
Okay,
just
so
go
to
over
find the critical numbers, we need to take the derivative. So product rule, right? So first one times the derivative of the second.
How would we take the derivative of that?
Negative 2x e to the negative x squared, okay? Plus the second one times the derivative of the first, right? And then unfortunately we need to do some math with this. So we do have to simplify. Oh. But I guess we already have a common denominator, huh? That's cool, me. All right, so how do I find the critical numbers? What's that? Because the top equals to 0 and the bottom equals to 0, because we're going to find some critical number also, yeah. But this will never be 0, because we talked about that already, right? So
What
we're
will
gonna
never
take
be 0 at
the bottom. So we're going to take the top and set it equal.
Why will never be 0?
Because this is a number, like 2.7 something, and no matter what.
Oh,
How
because
we use
it's
it.
0 power to 1.
Yeah. Okay, so then that means x squared equals 1/2 which means our critical numbers are plus or minus 1 over root 2. Which is the same thing they got. Don't have to look.
Except for suits.
Super excited.
I think it's a 1 over root 2.
How did I? Really?
Yeah, you really like
Yeah, no, I see that, but.
3
did
more
you
parts
do
of this
the,
problem and then one problem.
How come the whole thing's?
Oh, the square root of 1 is 1.
I know,
So I simplified that part.
Oh.
Okay. All right, finding intervals on which f of x is increasing and intervals on which it is decreasing. And then we want the coordinates of the local min and maxes. So we came up with the critical points being -1 root 2 and 1 root 2. So there wasn't any weird things going on here with undefined values or anything like that. So we can pretty much just pick a number, plug it in, and see what's going on. So what number? 0. So if you plug 0 into where? Derivative. What do you get? You get 0. If I plug 0 into here, then that's going to be 0. You get 1 on top, and you get 1 on the bottom, which is 1. But we don't really care about the value. We just care about the sign. It's positive, so that means it is increasing here, decreasing here, and decreasing here. Okay,
Can
so
you
it's,
show on the previous slide that you did that on, please?
good.
Wait. Good.
Okay, so find the intervals on which f of x is increasing.
I got it.
So it's increasing from -1 root 2 over root 2 to 1 over root 2. Right? Find the intervals on which it's decreasing. It is decreasing from -infinity to -1 over root 2 and 1 over root 2 to infinity. 2 to infinity. And the x coordinates of all local minimums and local maximums. So what is this, a maximum or a minimum?
Well, it's decreasing, so that's a minimum.
So it's decreasing and then increasing, so that means it's a maximum.
Wait, it's
That's a minimum.
That's a minimum. Which one's a maximum?
The negative one's a minimum.
Okay, just testing. Most of you failed.
I passed it.
And then that means that x equals 1 over root 2 is a maximum, right?
We have to find another. Wait. That's just the edge. Trying to get how you're not isn't that just where the
Well,
if you
because
just draw
it's graph is going, we figured out it's decreasing down to there.
Oh, it's
and
there.
Decreasing, so that means it's down
I
there.
just have to draw it.
Yeah. Okay, and then they also want the y coordinates of those. So
Where do we plug it into?
Where do you plug it in?
The original?
The original, because it says the y coordinates, not the y prime coordinates. It says the y coordinates, so plug it into the y equation, which was y equals x e to the -x squared. So if you plug in -1 over root 2, then you get -1 over root 2 times, what's -1 over root 2 squared? 1/2. So it'd be times e to the -1/2. Right? So I might think about rewriting that as -1 over root 2e. How do you feel about that?
Did you do that on the calculator?
Yeah, I think so. Actually, you probably couldn't, because at the beginning it says give exact values unless it says to. And this doesn't say to round, so you have to give an exact value. But I'm guessing that you could leave it like this,
No.
and you'd be okay. And then if I put in positive 1 over root 2, I'm going to get the same thing except it's going to be positive, right? All right. Oh, and they have in their answer key, they have negative 1 over root 2, even a negative 1 now. So there you go.
Now using the second fold. That's cool.
Okay, right, and then it says concave up, concave down, so we need to take a look at the second derivative in order to do that. So the first derivative was negative 2x squared plus 1.
Okay, by the way, that paper here is so weird.
That is disgusting.
Yeah, I'm sure it was.
Do you want to go quotient rule or product rule? Quotient rule. Okay, so low, b high, what's the derivative of negative 2x squared plus 1? Minus high. B low, what's the derivative of e to the x squared?
2x.
Over the square of what's below. What is e to the x squared squared?
Yeah. Like pickled asparagus.
What do you do? I don't think this is important. But if the bases are both the same, what do you do with the exponents? You add them. X squared plus x squared is 2x squared. So this would be e over 2x squared. We can just leave it like that. Okay, find the, okay, so concave up and concave down. So what?
At least we can just plug in 0.
Yeah.
2 plus.
Oh, boy. I got some.
What are you doing
Would that
now?
be plus?
I took this minus and this and put it in front.
Oh. Okay, you simplifying that.
Yeah, and I don't need to do anything with the bottom, right? Because it's never going to equal 0, so we don't care. Right? So negative 4x e to the x squared, this is going to be plus 2 times 2 is 4. X times x squared is x to the third. E to the x squared, and then minus 2x e to the x. So the good news there is that we can factor out a what? And a 2 and a x. So I'm going to say 2x e to the x squared gets factored out. So that gives me negative 2 there, plus 2x squared there, minus 1. So these are actually like terms we can combine those.
Yeah.
So that is 2x e to the x squared times negative 3 plus 2x squared. Okay, so this will never equal 0. Set this equal to 0, you add 3, divide by 2, and take the square root.
Which one will never equal 0?
2x, oh yeah, never mind. My bad. So x equals 0 is one option. If this equals 0.
So that can equal 0.
Yeah, it can. If I set that equal to 0, I would add 3, divide by 2, and then take the square root, right? So that would be, my other answers would be plus or minus root 3 over 2. Okay?
You should do it that fast in your algebra class.
If I start doing this in algebra, they would pay attention for about 10 seconds and then all right, so we make a sign chart again. And this time we have 0, we have negative root 3 over 2, and we have positive root 3 over 2.
plug in one.
Plug in 1, where is 1? Is it here, or is it here? Is it between 0 and root 3 over 2? Okay, so let's plug in 1.
You plug in one into the second.
Uh-huh. If you plug 1 into here, then this is going to be positive. I don't care what the actual value is, I just want to know that that part's going to be positive. If you plug 1 into here, then this comes out to be negative, and a positive times a negative is a negative. So that means in this region right here, it's concave down. Here, right here, it's concave up.
I never trusted that.
Oh, we have to find the y coordinates.
Uh-oh, Bruce is to the opposite.
What? Why?
Please contact Shannon Stein at 249-338-74-500-387. Her son is River Roush. Anybody know that person?
I have a sister.
Would she like to ask you some questions about the all
Oh, no. Oh, maybe.
Okay, so we got that going there, right?
Yep.
And then the inflection points are going to be these right here. And you can take and you can plug those into the original function. I trust that you can do that. Yeah, because
So
it wants the y
what?
coordinates
Repeat
of
that,
it.
please.
Okay, the inflection points are, this is going to be 0, 0. If you plug 0 into the original
Oh, so
function.
we just need to find the y coordinates of those.
This would be negative root 3 over 2 times negative root 3 over 2 e to the negative x squared, right?
Yeah.
So negative 3 halves. And this one would be root 3 over 2 comma root 3 over 2 e to the.
How'd you do that?
I plugged them into the original function. I did it in my head.
Okay. Why are you not telling me?
I thought you were going to say stupid secret.
No. Okay, and then the last one skips a curve.
Uh-oh. I don't like that. How are we going to know where these points are? Negative.
How are we going to know? We know where they are.
No, I mean, how are we going to know
Oh, you
where
have a
negative
scientific
root 3
calculator.
over 2 e to the...
You have a scientific calculator available to you.
Negative root 3.
Oh, how'd you do that?
By looking at the.
You know where it's concave up, concave down, you can ask.
Yeah, but how'd you just whip that out without putting it in the
Because he's throwing
So this was our minimum, negative square root of 1/2, comma, whatever it was, negative blah, 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 to the negative 1/2. This is our maximum, square root of 1/2, comma, root 1/2 e to the negative 1/2 there. Here's our intercept of 0, 0, and it's an inflection point, so it's concave up over here, concave down there. We have a vertical asymptote at x equals 0, and then there's an inflection point right around there and right around there where it changes from concave down to concave up. And that would be that square root of 3 halves, comma, like that, right?
It's hard to do.
How come there's no square root of
Negative squared is equal to negative x squared. Yes, it would be hard to come up with this on your own. I think it's only 2 points.
That's true.
Double?
Okay, pause.
Okay, the load must be suspended 6 meters below a high ceiling using cables attached to 2 supports that are 2 meters apart.
Here we go.
How far below the ceiling, labeled X, should the cables be joined to minimize the total length of cable used? What is the minimum amount of cable needed? So this is a minimization problem, right?
Wait, can we hear a story?
I just told you.
No, that's not a good story.
Oh, too bad Julie's not here.
Why?
Okay, class list.
Okay, so we want to minimize the amount of the cable needed, right?
Yes.
So we have to come up with a formula for the length of the cable that we're going to end up using. So this part right here is really easy because it says the whole thing is 6 meters below, and this piece right here is X meters below. So how much is the straight part? 6 minus X. Okay? Then we have to find these little pieces right here. But like Austin said, we know the whole distance is 2 meters. So we know this distance is 1, right? Right?
Yeah.
So if this distance is 1, this distance is X, then what's that distance right there? Square root of 1 plus X, because it's A squared plus B squared equals C squared. But there are 2 of those pieces. So that is what we are coming up with for the equation that we are trying to minimize. Okay? Super challenging?
There was more.
Really?
I wouldn't have gotten that though. Yeah.
You wouldn't have been able to get that?
So did you really just?
I would have made 2 equations.
Well, you could do 2 equations and just add them together, and then that's the whole thing. So again, what I did is I broke it down into 2 pieces.
Where'd you get the 2?
Where did I get the 2?
Yeah.
Oh, because there's 2 pieces. There's one right here and there's one right here. So this one is the square root of 1 plus X squared, and this one is the square root of 1 plus X squared. Right. This is Pythagorean theorem. They told us this distance was X, this whole thing is 2, so that's 1. Okay? What's the smallest that X could be? 0. In theory, it would be more efficient just to hang one right there. What's the biggest that X could be?
6.
6. Because we want it to be 6 meters below the thing. So all our answers have to be in between 0 and 6. Okay? All right. Then what do we do with this equation if we want to find the minimum length?
Derivative?
Make the derivative.
Just say I didn't show up.
So how do you do it?
Sour's not like fire.
A negative 1.
Okay, the 1.
This is like 2 to the 1 plus X squared to the 1 half, right?
Yeah.
So when you move the 1/2
What?
back this way.
Right, you put that in front and you go 1 plus X squared to the negative 1 half, because the 1 half and the 2 will cancel, and then you have to go times the derivative stuff inside 2x. Alright, so that is going to be negative 1 plus 2x over square root of 1 plus X squared. See, the golf practice round is actually today, where we went up on Saturday instead. And we did not practice this year.
Because it's raining.
Also, sad it was raining yesterday.
I enjoyed the rain yesterday. I used to just go, oh, it's rainy, can't do anything, just lay on the couch.
That's exactly what I did, because at Taylor's house, we were supposed to move this big dresser thing, but they go out and out, like, can't do it, it's raining.
Well, my lawn.
We're going to try to go camping on
Okay, both 2 nights? Okay, so then I need to get a,
Saturday. If
your
Brianna
father?
can go, you should talk to him.
I'm not gonna talk to her father, but.
She's being chicken. She won't do it.
Okay, so I have to get a common denominator, that's gonna be negative square root of 1 plus X squared.
You could tell him that you're chaperone.
Oh, yeah.
I wasn't even thinking about it.
Right, you guys see how I did that?
Yeah.
You say no? So this is going to be negative 1 plus X squared plus 2X all over square root of 1 plus X squared, right? Okay, then what do I have to do with that? Take the top and set it equal to 0.
Go back.
trying to find where we should connect the.
Or the most.
We want the least, we use the least amount of cable to make this happen.
Actually,
The least amount of cable would be,
I don't either.
people will be pretty better.
never, never.
Look at this.
Okay, so how do you solve that?
Gosh, you could be superstitious, you have to do it right. No, it's all ruined now.
I've never heard of it not two times.
Because it's not.
Wait,
I'm gonna put that over there, if that's your.
Never heard of it.
why should I do this?
And square root or something?
Then square both sides, so 4x squared equals 1 plus x squared. 3x squared equals 1. And then obviously we can't use a negative number because.
How do you do this like on a non-graphical
That's your
paper parentheses thing?
So my answer is that x equals the square root of 1/3. What did you say, Cody?
How do you do this on a graphical, or on a non-graphical up there, because you have to use parentheses? Scientific calculator. That you're not able to. But like, you have to plug it back in.
Oh, yeah, that's fine.
Yeah, like.
We can do that without a calculator.
There was
Um,
a spider. Ooh, that was really big.
So could you write this as a square root of?
Actually, no, it doesn't. Does it say for you to figure out what the length of the cable is?
Yeah.
Oh yeah, what is the minimum amount of cable needed? Okay, so yes, we need to take that and plug it back into our equation, but you don't need a graphic, you don't need any calculator.
Hey, it's all right.
So what are we
Right
doing
there,
now?
X equals 1.
Wait, what are we doing now?
You could, yeah.
Pause, pause, pause.
Plugging it back into the.
Okay, that's gonna tell us what?
You could, but we can do better than that. We're smart people. 6 minus, like Austin said, we'll make this 1 over root 3 plus 2 times, what's 1 plus 1/3?
1 1/3.
1 1/3 or 4/3. So the square root of 4/3 is 2 over root 3, right? And then we'll multiply that by 2, so that's going to give me 4 over root 3. So negative 1 over root 3 plus 4 over root 3 is going to be 6 plus 3 is the amount of cable that we need.
It's not the distance over the road.
That's the total amount.
And the root 1/3 is the.
Is the distance that the joining point is below the C squared.
But it couldn't be more specific.
And then the way that you can say that this is a minimum is if you plug in, so that's what we got when we plugged in x equals the square root of 1/3, right?
Yeah.
What do you get if you plug in 0?
Something positive.
Right. So if you plug in 0, then you get 8, which is bigger than this. Okay, so that's out. And then if you plug in 6, you get 6 minus 6 is 0, you get some huge, I don't know what. And so that's the smallest one, and so that means that it's the best. All right?
You only have one more.
All right, got one more. Let's get her in. And then,
And this class is so much shorter now. We don't have choice.
oh yeah, is that why? It's so nice. Thanks.
It's nice not to be in English.
Yeah.
Dude, we only have, is that
Especially
last
not
one?
pickle pairing.
Is it? High school? Makes me mad, 'cause this is a lot of people last Monday.
Dude, I've been seeing so many posts about people with their last name.
I know.
I saw a post from Grove, California, like graduation day. I was like, what the heck?
Today?
Yeah.
They graduate on Monday.
Okay.
Yes, so?
So we got a particle.
It's over here.
We got. Let's get this done.
What kind of?
I don't know what kind of particle. A boson is what this is. It's moving through the plane along the curve C, and we've got parametric equations for it. Hey,
Focus.
find the equations of the tangent line to the curve C at time t equals 1. Okay, you've got this. What are the two things you need for an equation of a line?
The slope and
Slope. Stop right there. How do we get the slope?
Take the derivative.
Take the derivative, and
Of
it's
which
dy dx. You take the derivative of both. And the y derivative goes over the x derivative. Okay? So the y derivative is 2t plus 4, and the x derivative
I didn't
is
realize that's
6t minus 4.
not bad.
What do I do to get an actual value for that?
Plug in 1.
Plug in 1, which says the time t equals 1. So that would be 6 over 2, which is 3. So our slope is 3. What's the other thing that we need?
A point.
Point. How do I get the point?
Plug in 1 to the.
Plug in 1 to the thing. So if I plug in 1 into this, 3 minus 4 is negative 1. If I plug in 1 into that, I get 1 plus 4 plus 4, which is 9. So the equation for my tangent line is y minus.
But I did not know how to do that.
You didn't know how to do what?
I didn't know how to do that by myself because I knew you had to take the derivative by
That's dy dx.
Interesting.
Yeah. Find the times when the tangent line to the curve at pt passes through the
So
point.
don't you just plug in 2
Zero.
for y?
What's that?
So you just plug in 2 for y and 2 for x? Or 2 for x and 0 for y?
Unfortunately, no. This one's a little bit brutal.
Yeah.
Yeah.
Oh, wait, because we're there.
Pretty good.